Right, we know frequency is related to area, so the first thing I'm going to work out is the area of each bar. So 40 up to 72 is 32 across, and it's 2, 4, 6, 8, 10 up. So its area is 320. The next one is 48 across, 10, 12, 14, 15. So it has an area of 720. Then 80 across, 6 up, and 120 across, and 4 up. Now these aren't the frequencies, but we're going to use this little fact here: 8 more days in this section than in this section. So it's actually, in terms of area, 160. So we know an area of 160 represents 8 days. So we need to divide everything by 20. So we've got 16, 36, 24 and 24. Once we've got this table of values, we can then, it says use your calculator, so we can just menu number 6, 1 variable. We need the midpoints of these. We can get the calculator to work out for us by adding the endpoints and dividing by 2. And we can sub in the frequencies. And we just have options, 1 variable calculations, and it automatically tells me that the mean is 144.32 and the standard deviation is 73.2 to 3 sig fig. So the first bit of actual calculating comes from finding the quartiles. So total frequency we've got 100 days. So Q1 is the 25th, which is in the group 72 up to 120. There are 16 results before that, and by the time we finish we've got up to 52, so 25th is somewhere in the middle. So we need to work out 72 plus 25 minus 16 over this gap of 36 multiplied by this gap, which is 48, and we get an answer of 84. Q3, Q1's the 25th, Q3 is the 75th, which is in the 120 to 200 region. We've got 52 up to that point, 76 as we leave it, so 75th is right up the top of this group. So it's 120 plus 75 minus 52 over 24 times 80. Have I got that right? factor range? Yes. So the interquartile range is the upper quartile, subtract the lower quartile of 84. Which is 112.6, so rounds to 113 to 3 significant figures. Can we model it with a normal distribution? Looking at the histogram, well, you can only have a normal distribution if this data is symmetric. So no, we can't. Not an appropriate model. As the data is not symmetric. Symmetric is the key word. Part E, looking at a new set of data, so we can ignore everything that's happened so far. We think it might be normally distributed with a mean of 177 and a standard deviation of 58.8 to give us these quartiles. That's two ways we could approach this. We could either work out the probability of x being less than 137, and we would expect this to be 25. So 7 normal CD minus 1,000 up to 137, 58.8, 177, and the probability is 0.248, which is pretty close to 0.25, which is what we'd expect for the lower quartile. Probability being above the upper quartile, we'd also expect to be about 0.25. And in fact it's 0.265. So this is exactly what we'd expect from the quartiles. So a suitable model. We could have worked this out the other way round and said, well, I know the probability of being less than the lower quartile needs to be 0.25, and therefore find out what the quartile is. For that we'd do inverse normal, 0.25 for our area, and we'd get that Q1 is 137, which is exactly the right answer. To be less than Q3 is 0.75, so we'd find that Q3 is 217 to 3 significant figures, which is a little off, but not bad. So still quite similar.